All right, finally an algebra problem. This is problem number 6 from the 2012 AMC 10B, problem 20. Okay, we have two players, Bernardo and Sylvia, who play the following game. An integer between 0 and 999 inclusive is selected and given to Bernardo. Whenever Bernardo receives a number, he doubles it and passes the result to Sylvia. Whenever Sylvia receives a number, she adds 50 to it and passes the result to Bernardo. The winner is the last person who produces a number less than 1000. Let n be the smallest initial number that results in a win for Bernardo. What is the sum of the digits of n? As with any large game such as this, it is always good to think about small examples. For example, Bernardo receives the number 0 initially, right? That's the number that they pick. Okay, then what will Bernardo do? Bernardo will double it and give it to Sylvia. So Sylvia will receive 0 also. Sylvia adds 50, passing the result to Bernardo, who doubles it. Sylvia adds 50. Bernardo doubles it, so becoming 300. Sylvia increases it by 50 again. Bernardo doubles it, and Sylvia adds 50. Finally, Bernardo doubles it, and we can see that the result is now no longer less than 1000. Remember that the winner is the last person who produces a number less than 1000. Since Sylvia produced 750, and then Bernardo receives 750, and then produces a number greater than 1000 or greater than or equal to 1000. Bernardo loses, and Sylvia is the last person to qualify, so Sylvia wins. So if we're looking at the initial number that results in a win for Bernardo, what is the sum of the digits of n? All right. So maybe let's walk through maybe one more example. Let's say Bernardo receives 100, doubles it and gets 200, passes that to Sylvia. Sylvia gets 250, passes that to Bernardo, who doubles it to 500. Sylvia adds 50 to it, 550, and then Bernardo gets 1100, which is also too much, so Sylvia wins once again, right? So we can see that there's a sort of bias here. In particular, intuition tells us that Bernardo isn't expected to win a lot of the time because Bernardo makes much larger jumps than Sylvia. So Sylvia's small jumps are more likely to stay below the 1000 margin, right? Or the sort of threshold there. Whereas Bernardo is very likely to, after doubling, right, to basically lose the game. So we just need to find the smallest initial number that results in a win for Bernardo. So that number is probably going to be pretty small. But how small exactly? Let's see. So let's suppose we start by selecting the number n between 0 and 999. Bernardo produces 2n. Sylvia produces 2n plus 50. And we can actually just think about this in a more general light after experimenting a bit. This is 4n plus 100. Sylvia then receives this and produces 4n plus 150. Bernardo will double it and get 8n plus 300. Sylvia will receive that, and we can keep going, right? Bernardo doubles that, 16n plus 700. Sylvia receives that and adds 50. And finally, Bernardo will double that and get 32n plus 1500, which is clearly greater than 1000. So at this point, Bernardo has already lost. So in this case, if any of these are the last number less than or equal to 1000, then Sylvia wins and we're sad. Otherwise, Bernardo wins. So for the smallest values of n, we're just thinking about how small can we make n such that we win. In other words, these numbers are the last numbers that are greater than or less than 1000 to be produced, and then it must follow that after Sylvia adds 50, that pushes it over the 1000 mark. So in this case, if we want n to be as small as possible, we want the game to go on as long as possible because the numbers are increasing over time, right? In particular, we want, if possible, for Bernardo to get basically win at this stage, right? Because that allows us to have the smallest values of n. For this case, we need the following condition. 16n plus 700 is less than 1000. However, 16n plus 1000, or 750, is greater than or equal to 1000, in which case Bernardo wins. Well, this just tells us that 16n is between, well, it's less than 300, but 16n is greater than or equal to 250. So as long as we satisfy these two, that is a qualifying n. In this case, we can see that the first one gives us n is less than 1, I think that's 18 points something, so 18.75, and then n is greater than or equal to, in this case, 15 points, 65, like 5/8, right? So in this case, we can see that the number has to be between basically 16 and 18 for the smallest possible value of 16, and that gives us a sum of digits of 7a.